This is the Sustainable Development and Environmental Design lecture on materials, recycling, carbon capture, and embodied energy.
Modern folks have learned to save their time and energy too. You don't have to work.
Americans live one of the most developed nations on earth with some of the highest quality of life. Our economic, educational, and cultural influences shape the growth of countries across the globe, and more people are seeking to live an American lifestyle. But can we really survive the growth of the American-style consumers? What price are we and the rest of the world paying for our material wealth? How much energy actually goes into the products that we buy? It may sound like a good idea to outsource labor to developing nations. Think about the amount of fossil fuels used on shipping all that product halfway across the world. This is just a portion of what is called embodied energy. Embodied energy is the sum total of energy necessary for a product to sustain its entire life cycle. This life cycle includes raw material extraction, transport, manufacture, assembly, installation, disassembly, and then finally deconstruction or decomposition. In the past 50 years alone, the world's population has used up as much natural resources as we have needed to sustain the entire course of human history before then. By 2050, the world's population is projected to be 8.9 billion people. In that time, the US alone will have gained 150 million people. That's 4 times the population of California, our most populous state. What does this mean when Americans take up 5% of the population, but account for 22% of global energy consumption? Per person, that's 31 times the amount that is used in India. Even the way we choose to eat presents sustainability issues. 56% of U.S. farmland is used for beef. We feed 85% of corn and 95% of oats we produce to livestock to support a fast food infrastructure that has Americans eating 200 billion excess calories per day. It takes 25 gallons of water to produce a pound of wheat, but it takes over 5,000 gallons of water to produce a pound of beef.
Thoughtful, well-informed material choices are extremely important in sustainable building design because of the extensive network of extraction, processing, and transportation that goes into the manufacture, delivery, and installation of those materials. We've just learned about embodied energy, which is the sum total of energy necessary for a product's life cycle. Embodied energy includes not just the energy used in making a product, but also includes the raw material extraction, the transportation, the manufacture, the assembly, the installation, the disassembly, the deconstruction, or even the decomposition of the product or material. We're going to strive to seek out construction materials and building systems that are low in embodied energy. One of the things that we've learned from the book Cradle to Cradle is about the tragedy of the commons, which is the depletion of shared resources by individuals who are acting independently from each other and rationally, according to each one's self-interest, but despite their understanding that depleting these common resources is detrimental to the group's long-term best interest, we still continue to do it. And we see this time and time again in the building trades, starting at the design and conceptual inception of a project all the way through the construction and operation and maintenance of buildings, and ultimately whether those buildings get demolished or reused. There's a lot of embodied energy in that process. The beginning of the embodied energy video we watched earlier on started with a commercial for a medallion home. I actually live in a medallion home, interestingly enough. It was a particular way of branding homes back in the 1960s, trying to show that they would be energy efficient, that all the appliances and would not necessarily be good for the environment. That was a concept that most people weren't really clued into at that point in time, but that electricity would make people's lives easier. We see similar notions of ease and convenience in the design and construction of buildings. The building materials we specify as architects or interior designers might contain high amounts of, let's say, recycled content, or maybe be manufactured from rapidly renewable resources. So we think, hey, this is great. But if those building materials have to be shipped all the way over from the other side of the world, the overall effort isn't sustainable and can be judged against what's known as the triple bottom line. The triple bottom line is a way of assessing the long-term effects and best practices of sustainable decisions. We should always look for solutions that balance the needs of people, planet, and profit, because all three of these combined make up sustainable systems in our world. Obviously, whatever decisions we make, they have to be thought of in terms of the people. In the case of building design, the people that are going to be occupying the project or somehow come in contact with it. Obviously, any endeavor needs to be profitable, not so much that it's going to make somebody fabulously wealthy, but it needs to be financially sustainable. Things need to be able to pay for themselves. And lastly, of course, every decision needs to take into account the environmental impact of our decisions. And so those are related to, of course, the planet. So whenever making a decision in building design, we can rely on the triple bottom line as a guide and a metric for making sure that our decisions and our process of selecting materials is taking into account these three different balanced considerations: people, planet, profit. Now, in order to help facilitate the decision-making process for sustainable, or what we might call green buildings, a nonprofit organization called the United States Green Building Council, USGBC, was formed in 1993. The USGBC soon developed the LEED rating system as a tool for rating and certifying the sustainability of a building project. The very first version of LEED 1.0 was released in 1998. LEED is an acronym that stands for Leadership in Energy and Environmental Design. LEED certified buildings save money and resources and have a positive impact on the health of occupants while promoting renewable clean energy. A major underlying focus of LEED is to address the significant connection between buildings and greenhouse gas emissions, particularly carbon emissions that cause global warming. In order to organize the LEED rating system, there are different credit categories as illustrated on this slide, each of which focuses on a different aspect of sustainability and the physical act of developing and constructing our cities. A LEED credit scorecard is used to measure the different sustainable aspects of a project and to be able to determine to what level of sustainability the project's achieving. LEED uses a four-tiered award system of certified being the lowest level of sustainability achieved, and then silver, gold, and platinum as successively better levels of sustainability. We'll notice that the credit checklist is organized by the different credit categories, in particular the one that we're concerned with right now, which is materials and resources. So we're going to take a look at some of these different LEED material and resource credits to understand how they can help inform our design and material selection process to be sustainable. The first core concept of sustainable material selection based on the LEED rating system is LEED Credit MR prerequisite number 1, storage and collection of recyclables. Now in the LEED rating system, they have what are called prerequisites, meaning that they have to be accomplished and satisfied irrespective of any other credits that a project might pursue. They're mandatory, they have to be done. So every project that's going to be LEED certified at one level or another has to have provisions for storing and collecting recyclables on site. And so the intent of this particular credit is to obviously reduce the amount of waste that's generated by the building occupants so that it doesn't become disposed of in landfills, but instead gets diverted to various resource material streams so it can be recycled or reused for other things. This is an interesting slide because it shows different material categories ranging from rubbers and leathers to different metals and glass and paper products, and to what extent that they are either recycled or disposed of in a landfill. You can also see the volume of material in the United States that's either consumed or recycled for each of these different material categories. Clearly, paper and paperware products are the largest by volume simply because they make up the lion's share of what's used as packaging for other materials. Think of everything you come in contact with, whether it's food or consumer goods, whatever it might be, that's often packaged in some sort of paper or paperboard box. It's important to keep in mind that recycling saves energy, but ultimately whether or not a particular material is going to be recycled is dependent on whether there's a market for those raw recycled materials to be purchased and transformed into other products. So it's very much a capitalist-based system, supply and demand. We also need to understand that there's two different types of recycling content. Pre-consumer content, which is material diverted from the waste stream during the manufacturing process. This is also known as post-industrial content. So you can imagine at a manufacturing facility, maybe they make windows for buildings. There's a certain amount of material waste in maybe the metal of the frame of the windows or the glass that's used for the glass panes. And so before that material ever leaves the factory, it can be collected and then recycled and reused, basically put back into the manufacturing process for new windows. Secondly, there's post-consumer content. This is what we're most familiar with because these are materials generated by the end users of a product that can no longer use that material for its intended purposes. So you can think of recycled water bottles or empty cereal boxes. Now, in the building industry, there are certain materials that are heavily recycled simply because it's very cost effective to do so. One of those materials is the metal aluminum. Aluminum is derived from the mineral bauxite, which is mined all throughout the world. You can see this picture on the left of an open pit mine in South Africa where they're extracting bauxite. There's a tremendous amount of energy consumed in order to transform bauxite and process it into the metal that we know of as aluminum. Generating 1 pound of new aluminum takes 35 times more energy to manufacture than 1 pound of new cement. And cement is a pretty energy and carbon intensive material by its own. So that's the reason that we see a lot of things like soda cans and even building material products recycled and then melted down and processed to create new products. So in the case of an aluminum window or aluminum storefront system like we see on the right, a high percentage of that content, maybe as much as 75 or 80% of that aluminum, comes from either post-consumer or pre-consumer recycled content. Another example of a building material that has a high recycled content is the decking material called Trex. And this is a product that's made of pre-consumer wood and sawdust, so meaning sawdust and wood chips that come from the lumber manufacturing process, as well as post-consumer HDPE, which is high-density polyethylene that we find in milk jugs and other similar containers. So this HDPE is basically melted down along with recycled grocery bags and other similar plastics to create a binder that can combine these wood chips and sawdust together to create a board product that's somewhat similar to wood. It actually can cut like wood. It sort of has a simulated faux grain on it to appear like wood, but it's a little bit of plasticky, obviously, because it's partially plastic. Now, this is a good example of what we would call downcycling a product, primarily because the plastics, the HDPE that's used in Trex, was never intended to be used as a building material. It wasn't supposed to be decking. So there may be negative long-term results of using a product like this. There might be health consequences as far as causing cancer or birth defects or other issues that we're not even aware of yet that are a result of taking this material that wasn't intended for this purpose and using it for something that, although it may seem clever at first, might actually cause more harm than good. Now, we've also learned from Cradle to Cradle that when something changes but doesn't lose its original value, it's called upcycling. So in the manufacture of Trex, there's actually a certain amount of raw, fresh HDPE plastic that has to be added to the mix in order for these boards to achieve the structural and performance characteristics required. That's obviously not a closed-loop recycling system. Now, it is possible for the materials and energy that we use as consumers to be upcycled. They don't simply have to be downcycled or cross-cycled. But let's take a look at another example so we understand what cross-cycling is, which is where energy or materials get used in new ways, but not effectively and not how the materials were originally designed to be used. So this example is called School of Fish. And it is a dining room that was constructed for a culinary school in Vancouver. And it's actually on the water in a bay, and it was constructed from 1,675 recycled 2-liter soda bottles. The problem with reusing materials or products in ways that they weren't originally intended is that these plastic bottles degrade, which occurs relatively quickly due to the UV rays from the sun and direct exposure to salt water. They'll eventually break down and leach their main ingredient, which is polyethylene tetraphthalate, PET, into the surrounding water, creating pollution. And it's interesting because petroleum-based plastics like this are inert, and inherently they're fairly resistant to salt. And the understanding's always been that there would be no negative effects to the material being in salt water. Research has found that actually some plastics decompose fairly rapidly in the ocean. And they found that plastic breaks down at much cooler temperatures than previously understood, and do so within as soon as a year of that trash or that bottle hitting the water. The degrading plastics leach potentially toxic chemicals such as bisphenol A into the ocean, which has been shown to interfere with the reproductive systems of animals and people. About 44% of all seabirds end up eating plastic, likely by mistake and often with fatal effects. Researchers have determined that there's over 267 different marine species that are affected by plastic garbage negatively. Similarly, they found that plastic basically acts like a sponge, that it actually can be 1,000,000 times more toxic than any toxins in the seawater itself, because plastic items tend to accumulate a surface layer of toxic chemicals that may be floating around in the seawater. Again, they're like sponges and they attract this stuff. So to utilize the plastic bottles in this case for buoyancy to support the platform for this dining room seems rather clever. Oh, we're reusing these plastic bottles, giving them another life. But in reality, it's actually creating an environmental hazard that we really don't know a lot about long term, and even in the short term, we've become aware that it creates environmental damage for the sea life, which ultimately is going to affect us as well. Now, plastics are ubiquitous. They're everywhere. Let's learn a little bit more about what plastics are and how they're manufactured so we can understand their relationship and the consequences of them in relation to sustainable building.